Hello everyone, and this is lesson 2 in the Introduction to Houdini series. So this lesson is less of a tutorial and more of a lecture. So I will be making some stuff, but you don't need to actually understand how I'm making it. You just need to understand the concept behind it. So the concept that I'm trying to explain with this video is what is a procedural system and what are the advantages of a procedural system. Because that's what makes, that is the one thing that makes Houdini extremely unique. Like if you've ever heard about Houdini, anyone talking about Houdini, then the term procedural sort of comes up quite a few times. So the question is, what exactly is it and what are the advantages of it? And more importantly, where can you fit it in your workflow? So it won't work everywhere, but you kind of have to, once you understand what it is, you can sort of figure out, where it will be useful in your day-to-day work. Okay, so the thing to remember is that almost all softwares have some kind of a procedural system. Okay, so the first thing would be, what exactly is a procedural system? So in order to understand that, let's take modeling as an example, because you can have procedural modeling, which is primarily where it comes in, but you can also have procedural animation. Visual effects is highly procedural in nature most of the times. So we'll take modeling as an example because it's sort of easier to explain it over there. Okay, so before we start, there was a question someone had asked me about what if instead of a mouse I'm using a pen, like I'm using like a Wacom tablet and a pen, then how do you navigate? So if you go to your pen settings, then usually most pens have like a button, and what you can do is you can remap that to a middle click and a right click. Like sometimes it's on pan and scroll. So don't use a pan and scroll, keep a middle click, and then that will allow you to do the same navigation that you're doing with your mouse. Alright, so let's take a look at the different types of modeling. So what are the different types of modeling? So primarily you have three of them. Okay, so you have what is called as the direct input method. The second method is parametric. And the third method is procedural. So let's start with direct input. Okay, so what exactly is the direct input method? So direct input is essentially when you take an object and you just start moving vertices, or you use something like ZBrush and you sculpt it. So basically you're directly interacting with the mesh and making whatever you want, which is how I would say we make about 60 to 70% of our objects, right? So whether you are modeling a character or you're making a car, or majority stuff, you're going to start with a box or a sphere and then apply whatever polygon modeling tool set that you have, and then move the objects and retopologize or whatever, and then come up with whatever you want to make. So basically something along these lines, where I can take a sphere and then just move the vertices and make something like this. Now the advantage of this is that it is extremely flexible and sort of very artist friendly. So you can it's almost like sculpting, right? So you just directly take an object and you move it and modify it and you make whatever you want. The disadvantage of it is it is very difficult to recreate the same stuff, right? So it's sort of like sketching, right? So if you sketch something, it's very difficult to sketch the exact same thing again. There'll always be changes, there'll always be imperfections. And it is destructive in the sense that you can't, once I have turned this sphere into that, it's very difficult to go back. Like I can't do this. Okay, it's very difficult because if you're using Max and you've applied something like edit poly, or you just collapse the mesh to an editable poly, you can never go back and get the parameters of the sphere. Like that is gone. So that's a direct input method. Okay, the second method, as I said, is essentially parametric. So parametric modeling is essentially when you are building something using parameters. Okay, so the simplest way would be like in Max, if you make a box, okay, or Cinema 4D or any of them. Okay, so this box has a set of parameters, right? So you can define the height of the box, or you can define, let's say, the width of the box. Okay, so it could be something like that, right? And then you can also do stuff like, I want to give it more segments. Okay, so I can take this, and maybe I just want like height segments. So you're not interacting directly with the mesh. You have a set of parameters, and then you can just modify those parameters and get whatever you want. More complex examples of that would be, let's say, some kind of a tree modeling system. Okay, like in Max you have the basic AEC extended trees. Okay, or something like, say, grow effects. Okay, wherein you can just take you can go from here to there without really having to interact directly with the mesh. You will just modify some parameters, define age, and then you can go all the way from here to there. Okay, like you can have like a simple small tree or like just a plant, and then just increase the age of it and it will turn into this without really having to do too much, or without really having to like directly interact with the tree. And Max also gives you other things, like you have those doors and windows stuff, wherein you have like a basic, right? You have like a basic door, okay, like that. And then it has different parameters wherein you can define whether the door is open or close, like that. Okay, or you can define like the thickness of this door. Okay, so you have like different things. You can define the frame. So you have like different parameters that you can modify. So a lot of architectural softwares also have a fair few like parametric objects, for staircases, for doors and windows, a variety of things. So this is parametric modeling. And the final that you get is essentially your procedural modeling. So what exactly is procedural modeling? So procedural modeling is essentially rule-based modeling. Okay, kind of like that would be another way to sort of describe it. So what you're doing, you are combining a set of rules and defining an object, okay, or defining a final result. And these rules are kind of flexible. So in the sense that if any one of them is modified or changed, it will directly affect the final object and it won't break the process. Okay, so you can turn off the rules, you can turn them on, you can remove them. You can also modify the input geometry, and you should keep getting a similar result no matter what you do. And it also, because of that kind of flexibility, it's also very easy to get a whole bunch of variations. Okay, so if you look at, so the simplest example would be something like the modifier stack in Max. Okay, wherein, let's say I've taken a box, then I applied a twist and I gave it a bend. Okay, so what you've done is, so all of these two things are your rules, where I'm saying, okay, take an input, this is my input. And I'm saying, take the input, you twist it, and then you bend it. I am not directly interacting with the geometry. Like I haven't taken any points and moved them around or anything like that. Okay, so the advantage of this is that no matter what the input is, like this little thing here, no matter what the input is, you will keep getting the same result. Okay, so even if I put a sphere over here, it's going to twist the sphere and bend it. If I put a character here, it's going to do the same thing. And even if I turn off one of them, then this will just become a bent object. Like if I turn it off, then I'll just get this, right? Like I won't get, like the twist will turn off, I'll just get this. Or if I turn this off, then I'll just get that. So the point is, the system remains flexible. Like you can turn things on and off, and also you can change your inputs and keep getting different results. So this at the basic level is a procedural system, okay, wherein you are defining a set of rules, and based on those rules you get a result. Okay, and you can arbitrarily sort of change the rules or change the input and keep getting different results, which is what makes it really flexible. Now another example of this would be the MoGraph system from Cinema 4D. So the MoGraph system in Cinema 4D is again a procedural system. Okay, so like what you're doing is, we have a box and then you have something like a cloner, right? So the cloner will duplicate the boxes. And then I have an effector, and I'm saying like this is a random effector. So basically I've taken these objects and then they're sort of like, randomly scaled up. or scale down, whatever. So these are my set of rules. So what I'm saying is like, this is my input. And no matter what my input is, I'll always get the same result. And I can also make modifications to the cloner, right? So if instead of this, I want like a circular array, then I can have a circular array, right? So I can have this, right? So I can go from here to here, and then this will again feed back into the random effector and it will randomize this. As I said, so most softwares have some kind of a procedural system in them. So if no matter what software you're coming from, you have probably used it. It just maybe you don't know that it was called like this is a procedural system. So Max, like the modifier stack, is a procedural system. If you look at them, like you have a variety of them, right? So the modifier stack is a procedural system, but not 100% procedural system. Okay, like once you start, it allows you to also do like direct input. So once you do direct input at certain level, then it might be difficult to go below that. Okay. Like let's say if I took a sphere and I did some edit poly on it, and then maybe I did a shell, and then I did a bend and a taper. So I can only go back down to the edit poly. If I go back down to the box and make changes to the segments, the system gets destroyed. So you have sort of a limited amount of proceduralism in there. Or if you look at Cinema 4D with the MoGraph stuff, that's procedural. Maya has the new MASH stuff, which is also procedural. Now here's the thing, right? So a procedural system doesn't need to be node based. Like it can be a list based system as well. Like MoGraph is not node based, right? It just gives you a list. So that's not important. Okay, but the point is that as long as it's letting you set up a set of rules using a bunch of modifiers, which can be repeated any number of times and sort of modified to get different results, that is in effect a procedural system. Or like Modo has recently sort of introduced a procedural modeling workflow. All right, so the question that comes up is what makes, if most of these are procedural systems, what makes Houdini so unique? So the point that comes up is just having a modifier stack or just having something like MoGraph doesn't really, the flexibility comes from how much of an access is the system giving you? Like how much of a low level access does the system give you, and what kind of flexibility it gives you? Then you can kind of fully utilize a procedural system. If you're just getting a few modifiers here and there, and then I can just stack up these 5 modifiers and get some result, fine. To that extent it's procedural. The rest of it doesn't really matter. Now, as a final thing, procedural systems can, especially in Houdini, can be converted to parametric systems. So within Houdini, you have this option called digital assets, okay, which is effectively, you can take the entire node network that you have built and collapse it down to a single node and expose just a few parameters and save it and then reuse it later. So it becomes more like a small plugin, okay, that you can use within Houdini. Okay, so from this standpoint, let's say if I have this bend, this twist bend thing. So what I can do is I can take all of this and collapse it down to a single object, okay, or a single modifier, wherein I just have like say 2 parameters. Like let's say I have like bend amount and I have twist amount. So I've effectively combined these two together and made a single modifier out of that. Okay, and this is from a Houdini standpoint, this is a digital asset. So this is what makes Houdini a little more unique as well. So we'll take a look at a couple of examples just to give you an idea of why the procedural system in Houdini is fairly unique because of the flexibility that it gives you. Now, I'll be making some stuff. You don't need to know how I'm making it because with the next lesson, we'll properly start off with, how to model and how to do all of that. This is just a lecture on explaining the advantages of a procedural system. So, don't worry if you don't understand, how did he make that node and how did he connect that node and any of that stuff. You don't need to worry about it. Okay, we'll do all of that once we get to the proper tutorials. Okay, Okay, so I'm going to start off by, let's say I want to make something fairly simple. Let's say what I want to do is I want to make like a gear. Okay, so I just want to create, like something like that. Okay, so this is basically what I want to make. Okay, so if we look at it from a fairly standard point of view, like how you would do it in most softwares, okay, and then how you do it procedurally. Now, the one thing to remember is the reason why most people sort of shy away a little from a procedural system like Houdini is because in the initial stages, or actually in most stages, it kind of slows down your process, because you can't just directly take objects and start sort of moving them around and do whatever you want. You have to slow yourself down, and you have to think a little logically, and you have to think from the standpoint that at a later stage, if I want to make changes to this, will I be able to make those without destroying the entire system that I have built? So as I go through these, you'll probably get an idea of why the system gets a little slow, but also why it provides you the kind of flexibility. So the reason why Houdini takes a little bit of time to for you to kind of get around to it is because you need to rewire your thinking a little bit of how you make objects and how you would make them in Houdini. Okay, so let's get started. So I'm just going to create like a simple geometry, and I'm going to jump in and I'm going to create like a tube, and we'll change this to polygon. I'm going to reduce the height. Okay, and this is basically it. So what I want to do is I want to select, let's say, every alternate face and just extrude it. Okay, so I'm going to select every alternate face. Yeah, and then I'll press tab and I'll take a poly extrude. Okay, and just extrude it and maybe give it a little bit of an inset. Okay, so the interesting thing with Houdini is, like, think of this as a modifier stack, except Houdini is representing it as nodes. Okay, that's the major difference. Okay, so this is, in a way, this is a modifier stack, except that you are just seeing it in a nodal fashion. Okay. Oh, and also we are in Houdini 16.5. Okay, there isn't too much of a difference, or actually there's very little difference from an interface standpoint, so it shouldn't be any issue. Okay, now once you've done this, okay, this is fine. Like, let's say this is what I want, but let's say at a later date, if I come in and I realize, like, hey, I would want to have more teeth to this. I just have like 6 of them, maybe I want 20. So what I would do is I'll come back to the tube and then I'll say, okay, I want 20 teeth. I've selected every alternate, so it should be about 40 columns, and that's what happens. So the first question is, why did that happen? Okay, is because I selected only 6 polygons, and the poly extrude is only remembers those 6 polygons. Okay, so it's not going to magically go like, hey, the user has selected more polygons, so I should automatically update. Like, it's not going to do that. So this is where the problem comes up. So the thing is, because Houdini from day one has always been a procedural system, it kind of knows that users are going to face these kind of issues, and it has built things that will allow you to make this more procedural in nature. So what we want is a way to maintain our selection in a more arbitrary fashion. Like, I don't want to manually go in and select. I want to have a system wherein I can say, okay, select every alternate face and just feed that to my poly extrude. Okay, so no matter how many number of faces I have, poly extrude will, like, this system will automatically select every alternate face, and poly extrude will automatically update it. So the question that comes up is that, do I have something like that? And Houdini does. So the nice thing here is Houdini allows you to directly modify or modify selections that you have made, okay, which is up here. Like, if you look at this, it's called a group. A group is a selection. From a Houdini standpoint, it's a selection. And if you can see, it's giving you numbers. So these actually are the polygon numbers. Like, if you come to the tube and if you turn on this button, see, these are the polygon numbers. And if I just look at my poly extrude, see, this, like, if I come in here, see, 1, 3, 5, 7, 9, 11. Those are the polygons that I had selected. See, this is like if I press W, see 1, 3, 5, let me turn off the grid. Yeah, so 1, 3, 5, 7, 9, 11. See, these are the ones that I had selected. And if I come in here and I make changes, let's say if I make it 13, see, I'm automatically adding to that. Or let's say if I say something like, 16 to 20, see, so it'll automatically add to that. So because Houdini is giving me access to this, I don't need to delete because traditionally what would you have to do? You'd have to delete the poly extrude and either redo the selection and redo a poly extrude, or then again just, add to the selection and again do a poly extrude and hope that you remember how much you had extruded. So, you extrude to the exact same amount again. But here, because Houdini is giving you access to the selection data itself, you can update it and the poly extrude updates automatically. But this is painstaking, right? You can't, if you have like 10,000 polygons, this would be a nightmare. So what we get instead is Houdini has something called as a group node. Okay, so if I come to group and you have something called group by range, and what this does is it by default selects polygons and it is asking you a range. So I can say select one of every two, and that's what you get. Okay, and then we can give it a name. So let's just call it extrude, and I feed this into my poly extrude. And what I do is I just change my group to extrude, and there you go. So now, no matter now since this is completely sort of math based or like a modifier based thing, no matter what changes I make here, because this is not directly dealing with a physical number, it's just dealing with this group. So whatever update happens to this group here, the poly extrude will keep updating that. Okay, so if I come in here and I say select one of every 3, okay, so it'll keep, it'll adjust that. If I say select one of every 4, it'll adjust that. So automatically everything keeps getting adjusted without me having to, manually update anything. So what you've done, okay, is we've built a system wherein we say take the input, select every alternate face, and then extrude it. So the flexibility that comes in now is no matter what the input is, it will always do the same thing. So if I take a sphere and let's say we'll change this to polygon, if I just input the sphere, see, I get the exact same result again. Okay, it just selects every alternate polygon and it will extrude it. Okay. Or if I change the sphere also to something like polygon mesh, see, that's what we get. Okay, so if I make some changes here, or if I make, so it doesn't matter anymore. Like the number of polygons just doesn't matter, because this will always select one of every 2. Okay, so it is a math-based selection, it doesn't matter. So if you want to get like even more flexible with this, let's say we want to select the top faces. Okay, so if I come to the sphere and I can take another group and I can say select by bounding box. Like in Max you have volume select. Okay, so this is kind of like the similar thing. So I can, let's say, select this and keep it here. Okay. And, let's plug in this directly. Okay. Now, because that is missing, it's giving me an error. So this is, I believe this is called group 1. Yeah. Okay. So let's call this group 1. See, now here is the fun part, right? So if I take this sphere and if I decide to move it before my selection, okay, because see, the grouping happens here, like after the move. Okay, so if I just try to move this, see, so when it comes into that bounding box area, polygons get extruded. Once it's out of the bounding box area, the polygons don't extrude. Okay, let's say if we come to here and we'll say individual elements, there we go. Okay, so you can actually animate this stuff then, like if I just take this and like, let me keep this down, like I can do alt click, come in here and I can extrude, like just move this around. Yeah. And so if I move this, see, so you effectively animated your poly extrude, okay, without really having to do anything, okay, like with just the bare minimalist amount of work. And then let's say within this, I want to, adjust it more and say, within the bounding box, it should only select every alternate face. Then I can actually do that as well. So let's say if I come in here and let's say this will also be called group 1. Okay. But this will, you can do like a little bit of math here. So I can say intersect with existing, or or subtract from existing. Okay, so what that will do is, if I feed this into poly extrude, see, so now it is still extruding, but now it's extruding the alternate faces. And this is with literally just, like 5 nodes. Okay, so you've applied 5 modifiers and managed to create something like this. Okay, so it's effectively like taking the max modifier stack and multiplying it by like 100. So the point I'm trying to make is what makes Houdini unique within the various procedural systems is that because it was always keeping proceduralism in mind, it gives you very low level access, which allows you to make really interesting stuff because they've thought of things. Like you get these kind of small modifiers which otherwise you wouldn't really think of, but because like I can access selection data and modify it and then feed that into my polygon tools, it gives me a lot of flexibility. Okay, now here's the fun part. This is not just for modeling. Okay, like let me get rid of the the animation here. Okay, this is not just for modeling. It's also for you can also feed this into animation, into particles, into whatever you want. Okay, so let's say if I take something like this and I'm going to create a group out of this. Let's call it part. Okay, and what I want to do is, let's say you decide that these top polygons, I want to emit particles from that. Okay, so what I can do is I can just, because I've made this, turn this into a selection, I can take a particle network. I can feed this into a particle network, and by default it's emitting from the entire object. And if I come in here, again, like don't think about this right now, just try to understand what I'm doing. And I can just say scatter onto surfaces, but use the group. So my group is part, and you can see that it's now emitting only from that. And then maybe I can just give it, let's say I'll just give it like a little bit of noise. So if you've used particle flow, this is kind of similar to that. Okay, so I'll just give it some noise. Okay, yeah, and the life is too much, so I'll just reduce that. Okay, so what you have is this. Okay, so this is where it becomes fun, right? So if I take this and if I get the animation back, you'll see like you have no particle animation, and then once this geometry comes in, you get the particle animation and then it goes away. See, so all of that automatically got fed into your particle system. Okay. Or like let's bypass that completely. So you get this. Okay. So anything if I bypass here, like if I turn off the group range, see this automatically is now happening from every polygon. Okay, like let me keep this here. Yeah. Okay. Or let's keep this. See. Okay. So now because we omitted the group range, now it's emitting from all of those polygons. Okay. If I bring this back, you're only emitting from the alternate polygons. Okay. If I bring back the tube, let's say we'll give it more height, give it more rows. If I feed in the tube, see now you're emitting from the tube. So no matter what input you give, because this system always remains live, it will automatically update and give you different results. And the really interesting part is that within this level, it doesn't treat anything, as being completely unique. You can access, like these are not particles. Think of them as just points. So even if I come in here and let's say if I take another group and I say, let's say half of these should be green. Okay, so I can just do a bounding box. I can say whatever is within this bounding box should be green. So I can just move it here. Yeah. And I can just apply a color to this. And this is called group 2. So we'll take group 2 and group 2 should be green. See. So once the emission happens, see those points are green. And again, like whatever input you want, you feed in that input, it will automatically update. And you can also like merge the two inputs. So just like that, we can pick up both these inputs. So we have the sphere and the tube. Like you can't really see it now because it's a little too much, but there you go. You're emitting from both the sphere and the tube. So this is basically what is the advantage of Houdini. Okay, from not just from like a visual effects standpoint, but also from a standard, modeling standpoint. Like even as I said, like even modeling like that simple gear, the reason why it becomes more flexible with Houdini is that because of the low level access that you get, you actually have taken a modeling operation and made it completely independent of any kind of direct input. Like you didn't have to go in and manually select any polygons. It was all done automatically. So you can make any number of changes and the system won't break. Okay, which traditionally, if you are manually selecting stuff and moving it around, if you add to that, if you go back and parametrically change like the number of segments and stuff, it just completely screws things up. Okay, now it's not that you can't do stuff like that with Houdini as well. Like Houdini, you can model a character in Houdini and it'll screw up the same way it'll screw up in Max. Like if you can move around vertices and do all of that stuff, but that isn't what Houdini is known for. Okay, it's basically stuff like this. Okay, wherein you can build these kind of complex systems, and the initial stage is as I said, the initial stage is always a little slow because you have to think it through. Like whatever you're trying to make, the idea always is, can I build it procedurally so that later on, if I want to come back and make changes, it will allow me to do that. And, it won't destroy the entire thing just because, for some random reason. So you have to sort of think your steps through before you start working on it. So that is what sort of, slows down the process in comparison to where I can just take a box and start moving vertices around and make whatever I want. But because of that, it also gives you this level of flexibility wherein you can continuously come back and make changes and it's not really a problem. Okay, like let's say you've done this and this is just a test, right? But later on, let's say you're a group of 2 people or like a team of 2, and this is supposed to be like for a logo animation, right? But the design of the logo isn't done as yet. Okay, so what you did is you just did this basic test by taking a sphere and just seeing what works. But the nice part is that once your partner has made the logo and modeled it, whatever, you can directly take that input and remove the sphere and feed in the logo over here, and the whole system will still work. Okay, so you haven't wasted that time. Okay, like that being the point, right? So you haven't at any point in time gone like, I did all of this, now once I get that I'll have to redo it and make changes and stuff like that. Like 90% of your work is already done. So that is essentially what a procedural system is, and the advantages of it. So once again, if you have any questions or if you're like thoroughly confused regarding this lesson, you can write me an email and ask me, or put a message on Vimeo. I'm also going to start uploading my videos to YouTube because I realized something, that YouTube actually has a very nice auto subtitle generation system, and it works shockingly well with an Indian accent. Like I saw one of my videos on FX Hive and I switched on the closed captions thingy, like the auto generate, and it did a fantastic job with it. So I figured, hey, I'll start uploading my videos to YouTube. So those of you who have a problem with understanding my accent, you can see the videos on YouTube. I think it will do a better job, okay, because you will get the subtitles. Okay, so once again, I hope this was useful, and if you have any questions, you can ask me on email or Vimeo or YouTube or Twitter, or I don't know, send me an owl if you want to. And yeah, so that's basically it, and I'll see you in the next lesson.